Imagine waking up tomorrow and discovering that the airplane you are about to board was not designed by human engineers. It was designed by artificial intelligence, built by robots, and powered by energy that does not burn a single drop of fossil fuel. That future is not decades away. It is happening right now, inside a factory somewhere in the industrial landscape of the United States, where Elon Musk and his technological ecosystem are converging toward one of the most ambitious and expensive aviation projects in history. A next-generation electric aircraft worth $350 million, conceived, optimized, and perfected by artificial intelligence. But there is something nobody has told you yet. Stay until the end of this documentary, because what you are about to discover about how this factory of the future truly works, and what this aircraft could permanently change in human history, will redefine everything you thought you knew about the limits of technology. On the outskirts of an American industrial city stands a structure that from the outside looks like an ordinary manufacturing plant. Gray steel walls, massive rooftops, no flashy signs. But inside, something radically different is taking place. This is Elon Musk's factory of the future. And here, the 8-hour workday does not exist. The lights never turn off. The machines never stop. Robotic arms move with a precision no human hand could ever replicate, operating at speeds that would make any traditional assembly line look obsolete. Yet what makes this place extraordinary is not the robots. It is the invisible brain controlling them. The artificial intelligence installed in this factory does not simply follow instructions. It learns. It corrects itself. It improves. Every movement of every component is monitored in real time by machine vision systems capable of detecting microscopic defects. Every weld, every assembly, every rivet, analyzed by algorithms trained on millions of engineering data points collected from the best aerospace experts in the world. This is not automation. This is intelligence applied at an industrial scale. And the product being born inside this facility is something the aviation industry has been waiting decades to see. A fully electric aircraft, unlike anything ever built before. $350 million. That is the value of a single unit of this aircraft, before one passenger even steps on board. But the price is not what makes it historic. What makes it historic is what it contains. Or more precisely, what it does not contain. No combustion turbines. No jet fuel. No carbon emissions at the aircraft level. This airplane runs on a next-generation electric propulsion system, powered by ultra-high-density batteries designed specifically for this project, using AI-driven simulations impossible to perform with human calculations alone. The fuselage design underwent more than 4 million virtual iterations. 4 million. In every simulation, the AI modified variables, wing angles, nose curvature, weight distribution, control surface geometry. It learned from every result, eliminating what failed without building a single physical prototype. What once required a decade of wind tunnel testing was solved in a matter of weeks. To understand what is happening in this factory, you must understand generative design, a process where engineers no longer draw every component themselves. Instead, they define the constraints: maximum weight, minimum strength, materials available, stress limits. The AI then generates thousands of possible solutions, evaluates them, refines them, and delivers designs no human engineer would have ever imagined. The structural components of this aircraft resemble biological forms more than traditional engineering, shapes inspired by bird bones, neural networks, and natural evolution itself. And yet, they outperform conventional designs. Inside Musk's ecosystem, one AI system in particular plays a critical role. Grok, developed by xAI. Grok acts as the invisible conductor of the factory, processing massive streams of engineering data in real time, predicting robotic failures before they happen, optimizing production flows, and autonomously adjusting manufacturing parameters in milliseconds. During the aircraft's development, the system absorbed decades of aerospace research, thousands of patents, accident reports, performance analyses from nearly every major commercial aircraft of the last 50 years. What would have taken teams of engineers years to process was completed in days. If Grok is the brain, Tesla's Optimus robots are the hands. These humanoid robots work alongside specialized human operators, handling delicate assembly tasks with sub-millimeter precision. The result is an assembly speed 400% faster than conventional aerospace manufacturing, with defect rates approaching zero. This is not science fiction anymore. It is a functioning production line, and its implications reach far beyond aviation. The airline industry currently produces nearly 900 million metric tons of carbon dioxide every year. One of the biggest obstacles to electric aviation has always been battery energy density. But according to sources close to the project, AI-designed solid-state battery architectures developed in this factory could triple the range of current electric aircraft. If those breakthroughs scale globally, aviation may never be the same again. The true significance of this project is not measured in dollars, but in what it represents for the future of human mobility. Today, flying remains one of the most polluting activities in modern life. The convergence of artificial intelligence, advanced robotics, and electric propulsion happening inside this factory represents the first serious industrial-scale attempt to change that reality forever. It is not a laboratory concept. It is not a design prototype. It is an active production line operating 24 hours a day, guided by a digital brain that never sleeps and robotic hands that never make mistakes. What you have seen today is not simply the story of a $350 million electric airplane. It is the story of how artificial intelligence is compressing decades of technological progress into years, how robotics is removing the physical limits of human manufacturing, and how the fusion of both is opening an entirely new era in the history of transportation. The sky was always considered the limit. Now, it seems not even the sky is enough. The implications of this technological revolution extend far beyond a single aircraft or a single factory. What is happening here represents a transformation in the very philosophy of manufacturing itself. For more than a century, industrial production has depended on one fundamental principle: humans design the systems, and machines execute the labor. But inside this new generation of AI-driven factories, that relationship is beginning to change. The machines are no longer just tools. They are becoming decision makers. Every second, millions of data points flow through neural networks, constantly evaluating efficiency, structural integrity, energy consumption, and production speed. The factory is evolving in real time, almost like a living organism, adapting to its environment. And that changes everything, because once a system can redesign itself faster than humans can react, technological progress stops moving in a straight line. It begins to accelerate exponentially. For the aviation industry, the consequences could be historic. Traditional aircraft development is one of the slowest and most expensive engineering processes on Earth. A single commercial aircraft can take over 10 years to develop, certify, and mass produce. Entire generations of engineers dedicate their careers to refining one platform. But artificial intelligence changes that equation completely. When simulations replace physical prototypes, when algorithms can test millions of aerodynamic configurations in days instead of years, the speed of innovation becomes almost impossible to comprehend. Aircraft that once would have taken decades to evolve may now improve continuously, in cycles measured in months. Every flight generates new data. Every new dataset makes the AI smarter. Every improvement feeds back into the next design. The airplane itself becomes part of a permanent learning system. And perhaps the most unsettling part of all this is how invisible the transition may appear at first. Passengers boarding these future aircraft may not even realize that the machine carrying them through the sky was designed largely by non-human intelligence. They will sit in quiet electric cabins, with almost no engine vibration, no deafening turbine roar, and dramatically lower operating costs. Airports may eventually transform into clean energy hubs, where aircraft recharge instead of refuel. Entire supply chains built around fossil fuels could begin to collapse. Oil demand from aviation, once considered impossible to replace, may decline faster than governments or corporations are prepared for. And if electric aviation becomes scalable for regional and eventually long-haul flights, the geopolitical balance of energy itself could shift permanently. Nations built on oil exports may face economic disruption on a scale comparable to the Industrial Revolution. But every technological leap creates new questions. And this one may create some of the biggest humanity has ever faced. What happens when artificial intelligence becomes better than humans at engineering? What happens when factories operate almost entirely autonomously? Millions of jobs across manufacturing, logistics, maintenance, and even design could fundamentally change or disappear. The same AI systems optimizing aircraft today could eventually optimize entire cities tomorrow. Transportation networks, shipping infrastructure, power grids. Passengers boarding these future aircraft may not even realize that the machine carrying them through the sky was designed largely by non-human intelligence. They will sit in quiet electric cabins, with almost no engine vibration, no deafening turbine roar, and dramatically lower operating costs. Airports may eventually transform into clean energy hubs, where aircraft recharge instead of refuel. Entire supply chains built around fossil fuels could begin to collapse. Oil demand from aviation, once considered impossible to replace, may decline faster than governments or corporations are prepared for. And if electric aviation becomes scalable for regional and eventually long-haul flights, the geopolitical balance of energy itself could shift permanently. Nations built on oil exports may face economic disruption on a scale comparable to the Industrial Revolution.